Okay, so in this video, we're going to be looking at some basic operations on complex numbers. In many ways, particularly when they're in I form, you could basically just treat I like a variable, with the caveat that if you get an I squared, you have to replace it with -1. But for the most part, you don't have to worry too much when you're dealing with I's about what I means. So if complex numbers are kind of freaking you out, think of it as a rule-based system, the same way you would treat a variable, and mostly this will work out. Well, we're going to see a couple of examples as we go through these problems where you have to worry about like what I is standing in for, and you have to use those rules to your advantage. But again, think of it as a rule-based system. And sometimes I find that if you are like not really sure what a complex number is, that's okay. If you work with it more, you'll find that you become more comfortable with it over time. Now, as I said, when it's written in I form and not as the square root of a negative number, you can treat it essentially like a variable in the same way that you would treat an x. So in a problem like this first one up here, what we're essentially going to do is we're going to combine like terms. So anything that is not an I is going to be a constant. It's going to be added together. And anything that contains an I is going to be treated together. And we're going to add those just like we would things that contain x. So in this particular case, if we distribute out our negatives, we have 7 plus 9, distributing the minus sign, minus 2i, distributing the minus sign, plus 17, another minus sign flip, plus I, and then 7 and 9 is 16. And then we're going to add 17 to it. 7 plus 9 plus 17 is going to be 33. And then we have a minus 2i and a plus I, and that's going to be minus I. And you don't have to do anything else with it beyond that. Combine like terms. Now, when you're applying a square root, the order of the order of operations is going to apply here. And so remember that when you multiply a binomial with a square, you are in fact multiplying the binomial by itself. And so that means you have to FOIL. So 2 times 2 is 4, 2 times 3i is 6i, and 3i times 2 is another 6i, and then 3i times 3i is going to be 9i squared. Now, when you get an I squared that's going to show up, then you're going to replace it. And I'm not going to do any combining like terms right away. I'm just going to replace my I squared with -1. That's by rule. If I is the square root of -1, when you square I squared is -1 without the square root. So that's the rule. And so now we have 4 minus 9 to get -5, and 6i is going to be 12i. Now, when we work with fractions, in order to split our terms into the standard form, a, no real part, plus bi, the complex part, then we can't have division like this. So we need to get the complex number out of the denominator. And so that means we're going to multiply by the conjugate. So -6i times 3 minus 2i, and then we're going to divide that by 3 plus 2i that was there originally, and another copy of 3 minus 2i. So again, the conjugate of a complex number is you take the imaginary part and you change the sign. Now, this essentially is going to turn our denominator into a difference of squares, and I squared is going to become -1. And so we're going to end up with only real numbers in the denominator because all the I terms are going to cancel out. Now let's see what happens up top. We distribute our 6i, we get 18i minus 6 times 2 is 12i squared. Again, just follow the rules for multiplying, just like you would variables. And then we'll simplify things later. Our denominator, again, difference of squares is going to be 9. We're going to get minus 6i plus 6i from the middle terms, which will cancel. And then minus 4i squared. We're going to replace all of our I squareds with minus 1. Nine minus 4 minus 1. Again, the 6i and minus 6i canceled in the denominator. Parentheses did not quite do what I wanted them to do in the numerator. That's better. And so now if we simplify our numerator, we're going to get, we've got negative 12 times negative 1, which is going to be positive 12, but it's being multiplied by a negative 1 on the outside. So it's going to be negative 12. And then negative times the 18i is going to be negative 18i. And then in the denominator, the negative 4 times the negative 1 is going to be plus 4, which is going to be 13. And so now we can rewrite this as negative 12 over 13 minus 18 over 13i. Now, this is something that your calculator, your TI calculator, can do if you update the mode on the mode screen, if you change it from real to a+bi. And then you'll have to convert to fractions to get it out of a decimal form. But this much, all of these 3 examples that we've just done, your TI calculator can handle that. Now, for these next 2 examples, you are going to need to do some rewriting yourself before you can let your TI handle them. If the square roots are not perfect square roots, you should do them by hand anyway, so that you don't have to deal with the decimals. Because these are not decimals, the calculator can convert back very easily. So here, before you do any multiplying, like in the next problem, or anything else, you need to convert these to the I notation. So our 5 is going to be, we're going to pull the negative out as an I, and then we'll simplify the square root of 8 to be 2 square root of 2, because it has 8 is 4 times 2. So the I takes care of the negative, and then 2 square root of 2 is the negative 8, is the square root of 8 simplified. And then same thing for the 18, we've got a 3. We take the negative sign out of the square root as an I, and then 18 factors into 9 and 2. So the square root of 9 is 3, so that comes out. And the square root of 2 is left behind. And so if we simplify this, we get 10i, well, let's say 10 times the square root of 2. I'm going to put these in, I'm going to put the I in front of the square root, just because sometimes people misread the I after the square root as being under the square root, and it's not under the square root. Normally you would put I after the constant, but I think this will be a little bit easier to read. And then in the second example, we've got 3 times 3 is 9i, and then another square root of 2. And now, because we have square roots of 2, we can add like terms together. 10i and 9i is 19i, and the square root of 2. Now we're going to follow a similar procedure for this next problem. There is a temptation when you're dealing with a problem like this to just multiply what's under the roots, but you'll lose a minus sign if you do that. So we're going to pull the i's out. So this will be 3i times the square root of positive 5, and then minus 4i times the square root of 12. And now what I'm going to multiply the coefficients and multiply the radicals. So 3i times negative 4i is going to be negative 12i squared. And then square root of 5 times square root of 12 is going to be the square root of 60. Now, the square root of 60 simplifies. It has a factor of 4. So I can bring that out as 2 square root with 15 left behind. And then up front, my I squared is going to get replaced with negative 1. And when I simplify that, negative 12 times negative 1 is going to be 12. 12 times 2 is 24, square root of 15. And again, you'll get the wrong sign if you don't rewrite this as an I first before you do the multiplying, because the negative will cancel out under the radical and you need it to be outside the radical. Now, for a problem like this last example, this is simply going to be using what we did in this problem, but simply doing it twice. Now, in this example, we have slightly different denominators, but they're conjugates of each other. So we're going to multiply the first expression by 2 minus I over 2 minus I. And we're going to multiply the second one by its conjugate, 2 plus I over 2 plus I. Now, we have to remember that the denominator will be the same, which will be good. The denominator, we can just, again, it's a perfect square, difference of squares, so we can FOIL. And so we'll get 2 times 2 is 4, 2 times I is 2i, and minus I times 2 is minus 2i. Those will cancel. And then minus I times I will give us minus I squared. We'll come back and simplify that later. But for both of these, we're going to need, I'm going to write it out because we're going to need to FOIL. One minus I, 2 plus I. Now let's think about our denominator. The plain I terms cancel. I squared gets replaced with minus 1. So minus a minus 1 becomes a plus 1. So our denominator just becomes a 5. So that's going to make life easier. And then up top, we're going to FOIL. So 1 and 2 is 2, 1 and minus I, and then I and 2 is going to be 2i, and I and minus I is going to be minus I squared. And then we're going to add to that 1 times 2 in the second pair is going to be 2. 1 times I is plus I, minus I times 2 is minus 2i, and then minus I times I is going to be minus I squared. Oops. And let's see, we have a minus 2i and a 2i. Those cancel. 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 And then minus I and plus I. That also cancels. And let's see what we have left. Our numerator is going to be 2 plus 2 is 4. And we have minus I squared and minus I squared. Remember, I squared is minus 1. So this is plus 1 and plus 1. So plus 2 divided by 5. And so we get 6 over 5. And there's no i's, in fact, that survive this process in this case because the numerators were also conjugates of each other. And so all the I terms ended up just canceling. Again, this was a little bit more complex. There's a lot to keep track of. feel free to simplify each expression separately and then add them together if you don't feel like this is too messy and it's difficult to follow. Then breaking it up into smaller chunks certainly helps. And then after you've simplified each of the two separate things that you're adding, then put them back together and then continue the process after that.